Welcome to the DIY Honda Garage channel. The DTC P2184 indicates a low voltage condition in the ECT, Engine Coolant Temperature Sensor 2 circuit, for the Honda HRV models from 2016 to 2022. This code is relevant to the Powertrain Control Module, PCM, and can affect vehicle performance and efficiency. The ECT sensor plays a crucial role in managing the engine's temperature and fuel injection by providing real-time data to the PCM. If this sensor misreports its readings due to a voltage issue, the engine may not optimize power, leading to potential overheating or underperformance. In this presentation, we'll explore the diagnostic process for troubleshooting this error code, gather insights into possible causes, and understand the steps to rectify the problem effectively. With careful examination and following the prescribed diagnostic steps, mechanics can identify the root cause of the DTC and ensure the engine operates within its optimal parameters. DTC P2184 reflects a low voltage condition detected within the ECT Sensor 2 circuit, which plays a pivotal role in monitoring the engine's coolant temperature. This sensor's data informs the Powertrain Control Module, PCM, about the coolant temperature, allowing the engine to adjust fuel injection and ignition timing accordingly. The ECT Sensor 2 is usually connected to the engine's cooling system, where it monitors the temperature of the coolant as it circulates through the engine block and radiator. When this sensor malfunctions or reports incorrect data, it can lead to improper engine operation, affecting efficiency and potentially causing damage over time. The PCM issues a warning, indicated by the DTC code, when it interprets a voltage reading from ECT Sensor 2 as being below the acceptable threshold of 0.08 volts. It's crucial for technicians to accurately assess this error to prevent ramifications on performance and emissions control. Several possible causes contribute to triggering DTC P2184. A primary suspect is a faulty ECT Sensor 2, which might be defective or failing to provide accurate voltage output. Additionally, the circuit wire running from the sensor to the PCM may have experienced a short to ground, causing the voltage to drop significantly. Poor connections or loose terminals at either the ECT Sensor 2 or the PCM can impede the circuit, leading to erroneous voltage readings. It's also possible that the PCM itself is malfunctioning, although this is less common. Inspecting the wiring and connections is vital before replacing any components, as often the issue lies not with the sensor, but with external factors affecting its operation. Proper diagnosis through testing protocols is essential to accurately pinpoint the cause of the low voltage reading. When DTC P2184 is present, there are several symptoms that may manifest. Drivers often report engine performance issues, including reduced power output or rough idling, as the engine's fuel injection may not be accurately calibrated due to incorrect coolant temperature readings. Additionally, poor fuel efficiency can be noticeable, as the engine attempts to compensate for the erroneous data it receives, leading to excess fuel consumption. In some cases, the vehicle may experience overheating conditions, particularly if the PCM cannot activate cooling fan controls effectively, creating a risk for engine damage. Moreover, the DTC will illuminate on the dashboard, prompting drivers to seek diagnostic services. Addressing these symptoms promptly is vital to prevent long-term damage and ensure optimal vehicle functionality. In troubleshooting Step 1 for DTC P2184, the first task is to turn the vehicle to the on mode without starting the engine. This allows the onboard diagnostic system to initialize, and the next step involves using the HDS, Honda Diagnostic System, to check specific parameter values. Technicians need to focus on the ECT Sensor 2's voltage output, which should read above the threshold level of 0.08 volts. If the current conditions match this threshold, it confirms the failure is duplicated, leading to step 2 in the troubleshooting process. Conversely, if the conditions do not match, this indicates an intermittent failure, suggesting that the system is currently functioning correctly. Under such circumstances, technicians must inspect the wiring and connectors to the ECT sensor and the PCM for issues such as poor connections or loose terminals, as these can lead to temporary faults. For Step 2 in troubleshooting DTC P2184, begin by turning the vehicle to the off-lock mode. This step is necessary to safely disconnect components without causing further electrical issues. Next, technicians must disconnect the ECT Sensor 2's 2P connector, allowing for an isolated test of the sensor's function. Afterwards, the vehicle should be turned back to the on mode again, without starting the engine. Using the HDS tool, check the output voltage for ECT Sensor 2 once more, ensuring it remains under the threshold of 0.08 volts. If the output voltage matches the expected low threshold, this indicates a fault within the sensor itself, confirming the need for its replacement. If the voltage reading is outside this range, the technician must consider further checks on the wiring and PCM, since the issue may not lie solely with the ECT sensor. In Step 3 of troubleshooting DTC P2184, the technician should turn the vehicle to off-lock mode once more. Following this, jump the SCS service connector switch line using the HDS tool and wait for more than 1 minute to allow the system to calibrate adequately. The next step is to disconnect the PCM connector A51P, isolating it to test for electrical continuity. A key aspect of this step is checking for continuity within the TW2 sensor wire, which connects the ECT sensor 2 to the PCM. This testing is performed using specific test points to ensure accurate measurements. Test point 1 is taken from the ECT sensor connector, specifically from the female terminal number 2, while test point 2 is measured at body ground. A positive continuity result indicates a short in the TW2 sensor wire that needs to be repaired before proceeding. Conversely, if there is no continuity, the wiring checks out and attention should be turned to other diagnostic procedures or potentially replacing the PCM. Once all troubleshooting steps have been conducted and repairs made for DTC P2184, it's vital to carry out a final verification of the repairs. Start by clearing the DTC from the vehicle's memory using the HDS tool, which resets the system and prepares it for a fresh diagnostic cycle. Following this, a test drive of the vehicle is essential to evaluate real-world conditions and ensure that repairs made have returned the system to proper functionality. During this test drive, technicians should pay attention to any performance issues and continuously monitor the dashboard for any reappearance of the DTC. If the code remains absent, it confirms successful repair. However, if the code reappears, further investigation is warranted. This final verification ensures that all issues have been resolved and the vehicle is operating within manufacturer's specifications. Preventive maintenance plays a crucial role in avoiding future occurrences of DTC P2184. Technicians should prioritize regular inspections of the wiring related to the ECT Sensor 2, making sure there's no wear or damage and that all connectors are in a pristine state. Ensuring solid connections at the sensor and PCM is vital, as loose or corroded terminals are common culprits for voltage issues. Scheduling routine diagnostics can assist in catching early signs of sensor failures or wiring problems, allowing for timely intervention before they lead to more significant faults. Additionally, maintaining proper coolant levels and using high-quality coolant can prevent overheating, which in turn protects the integrity of the ECT sensor. Educating vehicle owners on these maintenance tips can empower them to proactively manage their vehicle's health, improving longevity and performance. In conclusion, DTC P2184 serves as an important indicator of potential issues within the ECT Sensor 2 circuit for Honda HRV models between 2016 and 2022. This presentation provided a comprehensive overview of troubleshooting steps, including detailed processes for diagnosing low voltage conditions affecting the ECT sensor. Each step, from initial verification to final repair verification, was outlined to ensure clarity and thoroughness in the repair process. Moreover, we emphasize the necessity of preventive maintenance to foster long-term reliability and performance. Regular inspections and proactive measures can significantly mitigate the risk of recurrence. Ultimately, by following these guidelines, technicians can enhance their diagnostic skills and contribute to better vehicle upkeep, ensuring safety and efficiency for drivers. Please like and subscribe to the channel. See you next time.